Hello, and welcome to this comprehensive overview of computer networks. Today we're going to explore the fascinating world of network technology, from the basics to some more advanced concepts. Let's start with the fundamentals. A computer network is a group of interconnected devices that can communicate with each other. These networks form the backbone of our digital world, enabling everything from simple file sharing to complex global communications. Networks come in various sizes and types. The most common are LANs, or local area networks, which cover small areas like homes or offices. Then we have MANs, metropolitan area networks, covering larger areas like a city. WANs, or wide area networks, span even larger geographical areas. The internet itself is the largest WAN. Lastly, we have SANs, storage area networks, which are specialized high-speed networks for data storage access. When devices communicate on a network, they typically use one of two models: client-server or peer-to-peer. In the client-server model, clients request services from a central server. This is how most websites work. In peer-to-peer networks, each device can act as both client and server, which is common in file-sharing applications. Data transmission across networks happens in three main ways: unicast, one-to-one, broadcast, one-to-all, and multicast, one-to-many. These methods determine how data packets are addressed and delivered. Now let's talk about the physical components of a network. We have hosts, which are the end-user devices like computers or smartphones. Access points allow wireless devices to connect to a wired network. Switches direct traffic between devices on the same network, while routers connect different networks and direct traffic between them. The way these devices are arranged in a network is called its topology. Common topologies include star, where devices connect to a central hub; ring, where devices form a circular pattern; bus, where all devices connect to a single cable; and mesh, where devices interconnect with multiple others. Each topology has its advantages and use cases. Physical networks rely on various types of cables. Coaxial cables are used in cable TV and some Ethernet networks. Twisted pair cables, both shielded and unshielded, are common in office Ethernet networks. Fiber optic cables use light for data transmission and are the fastest option, capable of covering very long distances. These cables can be configured in different ways. Straight-through cables connect different types of devices. Crossover cables connect similar devices directly. And rollover, or console cables, are used for configuring network devices. Networks operate using protocols, which are sets of rules governing communication. Ethernet is the most common protocol for wired LANs, while Wi-Fi is used for wireless networks. TCP/IP is the fundamental protocol suite used for internet communication. For devices to communicate on a network, they need unique addresses. MAC addresses are hardware addresses assigned to network interfaces, while IP addresses are logical addresses used to route data across networks. We're currently transitioning from IPv4 to IPv6 due to the shortage of available IPv4 addresses. Security is a crucial aspect of modern networks. Firewalls act as barriers between trusted internal networks and untrusted external networks, while encryption protects data as it travels across networks. Networks continue to evolve with technologies like 5G, the Internet of Things, and edge computing. These advancements are shaping how we connect and communicate in the digital age.